about 30 seconds and then go ahead.
You all are much too polite. Most people are jeering by now, starting late, taking up your Friday time.
Late? Maybe those are on the wall.
Pardon? Oh.
Maybe the ones that are hanging on the wall are.
Yeah. You might want to close the doors. I don't know if it doesn't matter to me. So hello, I'm Terry Lahman. I'm a test manager for the systems test group in the Windows NT division. Part of engineering services. And this particular presentation is about the engineering process that we used on Windows 2000. It's a very high-level view of the testing effort we used to be able to ship a product of that size. I was one of 7 or 8 test managers that signed off on the product, so I was intimately involved with the effort. We've used this same similar presentation at a couple software testing conferences last year, and we thought we'd do it here on campus for people that were interested in this topic as well. I encourage you during the presentation, this is a very informal presentation. So if you have questions during any of the slides, please ask them while I'm talking about the subjects, and we'll answer those as best we can. What we're going to be going through today is we're going to talk a little bit about the organization of the Windows division and the different job categories and technology areas we have. We'll talk. I'll talk about the processes we used and the cycles we used for the daily, weekly cycles, and also how we did issue tracking. We'll talk about ship criteria and the tester's role in shipping the product. And we'll also talk about 3 key initiatives that we drove very hard during the Windows 2000 effort. The organization is such that there are 3 core feature teams or job categories that we focus on or use in the Windows product group. We have the program managers, developers, and testers. And we're going to look at a little bit more about the role of each of those in another slide. The organization is broken out by technologies areas. Some of the key ones are listed up there. We have the base operating systems, the kernel group. We have a networking team, server and client teams. We have a management systems management organization. We have CommPlus and web services. And then we have a number of other teams that we just kind of grouped in the other category. There's also some central services teams that provide a lot of the glue in being able to ship a product of this size. They provide a lot of infrastructure support like the build team, the UA team, the localization team, also the release management team that kind of coordinates the efforts between the product group, the release management, and these other teams. Pardon? It's the, somebody said it.
User assistance.
Yeah, the question was, what is UA? That's the user assistance groups, the documentation team. Also, part of that's the product support organizations and things. The other reason we have the central services is so that we can avoid redundancy between the groups. So each team doesn't have to have a lot of these services areas. We centralize a lot of that focus in the team. In this diagram, we try to demonstrate some of the interaction between the different job functions and how those might change during the product cycle. The program management team typically will put together the specifications and feature set that we're going to be using in the next product. Generally, those are reviewed at a higher level, and depending on the size of the feature or component area, will depend on how many people and what level they are to review that feature and component. The development team will work on a design spec, fairly typical, right? You write the feature and what it's going to look like to the customer. The developers will write a design spec of how that will be implemented into the product. At that point, we try to get the test organization involved quickly so that they're involved in the design process from the very beginning. One of the things we really try to emphasize is designing and building test and quality into the product from the very beginning. So the test organization will typically start working on the test plans and the release criteria for that feature and component area. Later in the presentation, I'll talk about the role of the tester and the different types of testing that we have going on in the organization. Eventually, we get into the heart of the product cycle where the dev team is implementing the feature and component, and the test team is working on their automation for being able to test that feature and component area. Project management will track the progress we make in that area. They'll also start doing potentially some usability studies. They'll be meeting with our joint development partners, our customers, to find out what features or how they want features implemented. Towards the end of the product cycle, we get into a fix mode where we are essentially code complete in the product cycle, and we're basically in fix mode. Now, we don't put bug fix mode on the slide because we're fixing issues. And I'll talk about that more later, but basically we think of issues as being both feedback from our customers in change requests they might have, and also the bug fixes that we need in the product. The test team at that point is mostly in a regression mode. As we take bug fixes, we're constantly rerunning our tests to make sure that we don't regress something that was working and suddenly it's broken. That's a major concern for us, is as we fix bugs or change features, that we don't regress things that were working. And then ultimately the official sign-off on the product. I'm going to show a video right now, if everything works correctly. This was a video put together a couple years ago, and it talks about it's called the daily life cycle, or the daily cycle. And let's see, we got that up.
The daily cycle for Windows 2000 begins when the newest build is released at 6 p.m. As our testing teams settle in for the evening, they install the build on hundreds of clients and servers, which simulate the work of hundreds of thousands of users. With this magnitude of a product, automation is the only way to achieve the level of testing required. After team members initiate the automated stress test, they focus on refining the more than 10 million lines of testing code that serve as the frontline proving grounds for the product's overall reliability. At 5 a.m., the remote diagnostics process begins. The logs for the overnight stress tests are carefully analyzed, then posted on a web page, so that any team member can monitor quantitative results at any time. By 9 a.m., the stress and bug reports are sent to team members. At 9:30, team leads representing every system component assemble to prioritize which bugs get fixed that day. Over the next several hours, developers begin making fixes. Before they check in any changes, they must compile their code using the most recent build, run functional tests, and submit their code to dev leads for a line-by-line review. Team leads carefully track component integration issues to ensure system robustness, as well as a consistent user experience. In the meantime, our hardware labs are busy round the clock, sorting out compatibility issues for some 580 OEM systems and more than 3,000 devices. For Windows 2000, our labs will test 500 LAN adapters, 1,400 printers, 370 display adapters, and more than 2,600 modems. Every day we add more devices to the test matrix, so that by the time we ship Windows 2000, we'll have maximum compatibility coverage. Testing continues outside the labs with teams dedicated to networking, security, and large-scale deployment issues. For example, the networking group maintains one server that handles more than 20,000 net meeting sessions per night, and another server that logs 2 million remote access calls during a single stress run. Other teams focus on integration of services, such as routing, virtual private networks, and the domain name system. Thanks to new specialized testing procedures, we have uncovered and eliminated hundreds of memory leaks and dozens of blue screen bugs, along with 45 configuration scenarios that forced a system reboot. Appropriate bug fixes have been backported to Windows NT 4. Even if the development team fixes every bug our testers find, we won't ship Windows 2000 until customers say it's ready. The team's daily routine therefore includes conference calls, briefings, and training sessions with key IT customers enrolled in the Rapid Deployment Program. And while the team tests more than 1,000 applications for compatibility, Microsoft's Developer Relations Group works with even more independent software vendors to test and incorporate new services into their products. Back in the lab, approved code changes arrive by 3 p.m., and the team goes to work assembling the new build. Before it's released, the build is installed and tested for integrity. Then it's automatically distributed over the network. And at 6 p.m., as the day's build goes out the door, the process starts all over again.
So one of the things I want to point out kind of while I'm here on this particular computer is this is my laptop from work. And one of the areas we're going to talk about later is the self-hosting and usage of our own system. And I just want to point out that I'm running an older version of the operating system right now. This one actually came out on Monday. It was available to me. So I feel a little guilty that I'm not running something newer. But this is kind of the attitude and approach we take in the Windows group is eating our own dog food. That is self-hosting on our own product. This particular version of the operating system was actually compiled on Saturday. CDs were burned Sunday. Monday I picked up mine. I think I installed it Wednesday afternoon. So we do believe in our own product. Let's see if... Yes?
Every day you have the same routine.
Yes.
Suppose you come across a problem which you need more hours to think of than this routine allows you. What do you do?
Okay. Hold that question. The question is, suppose we come across something really bad that interrupts the routine. Is that?
There's some problem which you don't see immediately what to do. You have to think.
Okay. Let me go through the test cycles we go through and see if I address that. But yes, it's like hitting a speed bump, isn't it?
Right.
Well, you do the same thing as when you hit a speed bump. You kind of slow down, and the routine gets interrupted a little bit. But the cycles we go through, there's 3 main cycles we go through. The daily, a weekly type cycle, and the milestone cycle for release candidates and betas of the product. The daily cycle begins very early in the morning for some of the teams. Some of the teams come in around 6 or 6:30 in the morning to start collecting data from the previous day's results. Every day at 9:30, every day of the week at 9:30, is what we affectionately call our war room meeting. And in this meeting, we review the key indicators of the quality of the product. Okay, and we look at daily information that typically focuses around things like what's the current status of the daily build, what issues did we run into on the daily build, what's the current status of the build verification tests that are run every day, what's the current status of stress test results from the night before, what's the current status of long-haul machines and deployment servers in key component areas. We'll also typically focus on any area that's having a lot of problems at that particular point in time. So for example, if some component within the operating system has got low pass rates, we might put additional focus on that information each day until we get it up to our passing expectations. The weekly cycle, yes?
The product builds, why do you need a build verification test after the fact?
After we build the product?
I mean, part of the daily cycle is a BVT, right?
Yes.
What function does that serve other than to confirm what you just saw, which was that the build completed or failed, right?
Okay, so let me describe a build verification test. The question is basically, what is a build verification test? What we go through each day is after we complete the build cycle, they do some boot verification tests on some set of machines. So basically all they do is install the build on the machine and make sure it boots up. At that point, they release the build to the build verification test team, the BVTs. And they run a series of tests on those machines. Those tests take between 3 to 4 hours to run. And they test all the core functionality of the operating system to make sure that the file system works, the redirector works, COM+ works, the shell runs, just general functionality. That's the build verification test. And by doing that, we're able to spot like easy failures or huge blocking issues. What we don't want to do is we don't want to release the build to literally 100 labs, install it on a couple thousand machines, and find out that the redirector doesn't work and you can't open a file across the network. That'd be really bad because now you've got thousands of machines not testing the product efficiently. And so if there is you asked earlier about what if there's a major blockage, build verification tests would be an example of that, where if we find a major failure during build verification tests, very high priority. There's a developer down in that lab very quickly to find out what regressed and what's failing. And it's their responsibility to get that bug fixed immediately for that build. Did that answer your question?
Yeah.
Okay. The weekly cycle, during about the last year of Windows 2000, we had a weekly cycle where we targeted a key build, typically Wednesday's build, as being an IDW quality. IDW is an independent developer workstation. And to qualify, there's a set of criteria we use to satisfy the IDW standard. And it basically amounts to a typical developer is able to do their job on that version of the platform, of the operating system. So that means they can compile the operating system, they can use Word, they can use Excel, they can use Outlook and read mail, they can open and close files, and essentially do their job. And by making it an IDW quality, everyone in the organization is assured that by installing that build that day, that it's going to work for them and they can still do their job. And the IDS is Independent Deployment Server. IDS builds were targeted about every 2 weeks. And the quality expectation there is that we can deploy all of the major services within our organization. So we can deploy it as a file server, a DHCP server, domain controller, print servers. All of the server-oriented services in the operating system would be of high enough quality to deploy within the organization. This way we get a lot better coverage of the operating system by moving it onto more and more platforms, more and more machines. The release candidate and beta cycle, on weekly builds, there are also, within each of the test organizations, sets of tests that take between 1 and 2 weeks to run. So regression tests that might take a week to run are run essentially every week. They run through those tests. The goal is such that the majority of regression tests can be run within the 2-week period to coincide with the IDS cycle, mostly, so that we can get the major code paths hit through our automation. And that's why our automated test paths are just critical to our success, so that we can easily launch these tests, let them run on machines 24 hours a day. The testing that we do is typically ongoing 24 hours a day, 7 days a week through these regression tests. There's also a weekly test results meeting. Each week, all of the key test managers from the different functional and component areas met to report their current test status, how many of their tests they've executed, what the current pass rate is, what their goal is for that particular milestone, how well they're doing to meet that goal. Have they completed all setup variations for all the different upgrade paths we support, clean installs that we support? The release candidate and beta cycles, these are more our system level testing. Some of our test paths may take 4 to 8 weeks to complete. Application compatibility is an example of that. It's very labor intensive. It's a manual process. We don't have automation because the hundreds of applications we test go through their own sets of revisions. And so that cycle is much longer. Some of the other tests that we run, long haul and deployment, some of those take much longer to run for each of the cycles. And then we, at the completion of just before our major milestones, we go through a very formal sign-off process for the product. This kind of shows how we view what we just looked at in the cycles. The idea is that from each build, from our daily cycle to our weekly cycle and our milestone cycle, that the quality continues to improve and just gets better and better, and that the user base, the number of people using the operating system, just keeps getting larger and larger. I'll talk a little bit later about criteria for each of these, but basically the criteria for each of these just gets harder and higher in terms of the bar that we measure. So a daily build just has to pass BVTs. We release it to the testing organizations. The weekly builds, they have to test that week's regression tests. They have to meet certain stress criteria and group testing criteria. And we also have a self-host group of people. These are the, what's the right word, pioneers that venture off on these new builds. They're the first ones to install these new versions each week. People like myself that are running this week's build to make sure I can do my job and try different applications and make sure it works. Well, we get to vote, and they basically have to have a certain number of people voting yes, we can do our job on this. And if we don't have that number, the question is why? What bugs did we hit that prevented it? And we get back to your speed bump, right? If we don't meet the criteria, then we don't sign off on that daily build or that weekly build, and we don't self-host on it. We don't declare it an IDW. Yes?
In that last 1 year, how often was it the case that we didn't meet the criteria?
Say the question is, during that last year of Windows 2000 development, how often did we not meet the criteria? Oh, once or twice, maybe a few more times. Many times. I'm going to be honest. Many times we did not meet the criteria. And that kind of reflects the importance of testing at Microsoft. You know, Microsoft puts so much weight on their test organization, and they give us a lot of ability to stop the release of the product. To give you a worst, I guess I'd call it best case example, I know one of our beta releases that we had, we delayed the milestone 1 week because the testing organization needed that time to ensure we didn't regress an important bug fix. We had to take a critical bug fix at the last minute, and we told management it's going to take us 2 weeks to effectively and thoroughly test this fix to know that we can meet our criteria and it won't hose the customer. And we delayed the milestone. And that's a huge impact to delay a beta release by 1 week. But we had the ability to do that because it was the right thing to do because we didn't meet our ship criteria for that release. And yes, there were many IDWs and IDSs that might get delayed some day or two or week. In a worst case, we might just cancel that week's attempt if it was bad enough. I think I'm answering some of your question there, aren't I? With different examples, because there are different examples for each of the milestones that we usually target. So a couple of numbers I had up here. We, in the testing organization, when a build came out, there were over 2,000 installs per day, typically, in test machines. We typically burned about 1,000 CDs per day, and we had about 300 servers deployed on IDS builds within the NT organization. Another key area that we had targeted within that pyramid I just showed too were executive deployments and deployments through the IT organization were another big area that we targeted in our testing. There was an executive deployment team that went through the executives at Microsoft from Bill Gates down to upgrade their machines to Windows 2000. We had people all the way from Bill all the way down to receptionists in our lobbies running Windows 2000 during our development cycle. Everybody in the Windows division obviously was self-hosting on our product. Yeah, we always refer to it as eating our own dog food. We are very adamant about that people in our organization use our product to get our jobs done. And if we ever hear somebody say, well, I can't use it because it's broken or it doesn't do the job, right away we're on top of that to find out why not. What's the bug number for that? Let's go drive that through the war room. Let's get that fixed. Our issue tracking process, one of the keys to our success in the Windows division through all this testing effort and releasing the product was having an efficient way to collect the data and test results and also the feedback we get from people self-hosting within Microsoft and our customers that deploy our beta versions or our joint development partners that used interim IDS builds for their testing. We collect all that data into a database, and then we have triage teams that go through every single bug to figure out what the impact is, who reported it. We assign a priority to it. So clearly bugs that came straight from our customers were given a high priority because they're seeing it on their systems. And if one customer sees it, then there's a high probability another customer might see it. We have long-haul testing on all of our services that we ship in the server version of Windows 2000. Long-haul testing is we put our machines under heavy load over an extended period of time. For example, we try to cram 3 to 5 months of transactions into a 10-day period. So on our IIS server, that means serving up web pages. On our Exchange server, that means trading mail. On our file server, that means bytes transferred and files transferred, open and closed on that file server. It helps us look for leaks in the system and for stability over an extended period of time. if we hit a bug on a long haul or deployed server, immediately got a very high focus, and it was a must-fix issue because we knew if we hit it over a couple of weeks, some customer might hit that in a few months. The triage teams would go through all those bugs and prioritize, assign them to their development teams for fixing. Those were reviewed at the appropriate level during the product cycle. During the last 3 or 4 months of Windows 2000 development, every single bug fix that went into the product was reviewed in our daily war room meeting as part of that process, because we did not want to risk destabilizing the product by taking any old bug fix. We wanted to make sure it was critical to the product, that it had been reviewed, that it had been thoroughly tested, that people were willing to sign on the dotted line, yes, this bug fix is ready to go in. Even after the fix went in, we go through an extensive verification process to make sure that that bug is fixed properly and that there's no regressions in that component area or any areas that utilize that. Then we go back into our release cycle, daily builds, weekly builds, IDS, and our milestone releases. During, yes?
So, pick a point in this cycle. And within the past few days, there have been a bunch of changes to the operating system and the other associated services. So the bugs that you find in the next interval, what fraction of those are related to the changes, and what fraction of those are due to bugs that were there before the changes occurred?
Okay, so let me see if I can paraphrase your question, make sure I understand. You asked when we take in. After we've taken in some number of bug fixes and we continue our testing, what portion of the new bugs are related to
the change code, or
is it to the modified code?
Yeah.
Okay.
Or what fraction of them are just things that you found that were there before?
Okay. I don't have a good answer for that. I know roughly where we are today in the product cycle. I don't know how that compares with where we were during Windows 2000. If you want to talk to me afterwards, I can tell you, I can give you some vague numbers they're mostly my perception and some measurements I know we took along the way. Ship criteria, this was a key focus during the Windows 2000 development to make sure we understood the metrics we were using for each of the releases of the product, our daily release, our IDS, our major milestones, and also how our customers and partners were involved with us to ship the product. So internally, we had our internal test group, and each component and feature area was responsible to define their ship criteria for each of the releases and milestones. So some team might say, okay, to release the RTM, the final version, we have to have 100% attempt of all our tests, and they have to pass 99.5% of those tests with no blocking issues. And that's why I put the qualifier in there. Sometimes a test will fail just for no good reason other than, oh, gee, there was a network storm at that particular point in time, and the test interpreted that incorrectly as a failure. So you may not achieve 100% pass rate, but that doesn't mean that there's a bad bug there that's going to impact the customer. So we did that for all the different kinds of tests we run, for our regression tests, our stress tests, our long haul, our deployment tests. There was a specific and clearly communicated set of criteria to define how we were going to sign off on the product. We also work closely with our joint development partners, our rapid deployment partners, our ISVs, IHVs, and to get their approvals and sign off on the product. There was a call down team that called this big long list of customers, executives at these companies, to ensure that, yes, they would sign off on our product because they had tested their line of business applications. Yes, they had deployed it on their servers internally. Yes, they were going to sign off on the product. We also work internally with our partners. We've got our PSS group. Partners are also our own IT shop here at Microsoft, the ITG group, to get their sign off on the product because they'd been running the various releases on their servers. And then we had the official sign off process. This wasn't simply a, if you vote, raise your hand, you vote yes. This was an official sign off process. We had a website set up. There were over 4,000 areas that had to get approved and signed off by various test leads, test managers, and testers before we would ship Windows 2000. I want to talk a little bit about the test team's role in Windows 2000 testing. We used to quote lines of code, but we've kind of gotten away from that. But I will give you a couple of numbers regarding the testing effort. During Windows 2000 development, for every one developer, there was approximately 1.7 testers. The number of people in the test organization outnumbered the people in the development organization. That's how important testing is to Microsoft and to the Windows division. The other information I'll give is, and this is an approximation again, but for every 3 lines of product code, there are approximately 2 lines of test code or script or automation. A huge, significant number of effort goes into the testing of Windows at Microsoft. The tester is also the customer advocate, right? They're representing the customer. And we'll work very closely with our ISVs, our independent software vendors, and IHVs, independent hardware vendors, so that we can focus on API level testing and the interface level testing. And the logo kits, the DDKs that we ship out to our customers are a major focus. We have a lot of events working with these people to get them onto the new platform, help educate them on how to write high-quality drivers in the product. One of the cool things we had for Windows 2000 that significantly increased the quality of the operating system and the drivers our vendors create was a driver verification tool that was created that really hammers on the device driver to expose blue screens in the system. We were able to drive down blue screens significantly using that tool and by actively engaging our vendors. Also, the administration of our sites in the server space. The testing organization is that advocate that looks for usability issues and ability to administer the site. And also the end user experience is a key focus area. We do most of our efforts go into the component level testing. That is, my team tests the file system, therefore we're going to ensure that all the APIs that the file system exposes work properly. We're going to exercise the file system in a lot of different ways. We're going to look at limit conditions, boundary conditions, all the different types of testing we can think of and go work on in this space typically fall into the component area. We also put a lot of focus on system level testing, and I've got a long list here, but the idea is to make each test organization think about and test their component and feature area in different categories that may apply to them. For example, compatibility, reliability, and robustness, ensuring that even under low memory conditions, that feature or component doesn't just crash the system, that there's some sort of error handling and that it fails gracefully for the user. Setup testing was another key area that was very important to us, making sure that each component works after upgrading from different platforms onto Windows 2000. Also, clean installs on a variety of hardware. Yes?
You don't say much about documentation. Is it getting better and better, or is it getting more and more neglected?
Documentation, you mean the
whole thing?
The book that comes with the operating system, or the help systems?
In any form.
Okay, so the question is, what are we doing about documentation in the operating system? I don't have a good answer for you. I do know that we, Microsoft, are expending a lot of energy in this space to better document how to do things. I know one of the cool features in Windows 2000 was the addition of over 20 wizards to make it easier to configure the operating system on both the client and the server space. Things like adding printers, connecting to networks. The RAS dial-up systems had a lot better wizards. And yes, the help system was much improved on Windows 2000 over NT4. A lot of effort was spent in that space.
So testers don't do documentation.
The testers do deal with some of the documentation from a technical accuracy perspective. For example, in one of the component areas I owned on Windows 2000, the UA group sent over drafts of the documentation to ensure that the technical information they put was accurate. And for me, that was a high priority, and I always assigned people and gave them time to go off and review the technical accuracy of the documentation. Yes, that's important to testers. We don't typically spend a lot of time on it, mostly because the documentation people are pretty much active in our organization. They would attend, typically might attend one meeting per month with our component area team to update us on what they were working on and their current status and when to expect draft copies of the documentation. Another thing I wanted to talk about on this slide is the different types of positions in the Windows division that testers are typically in. We have software test engineers, STEs, and software design engineers in test. They're the SDETs. And in the Windows division, sometimes there's not much difference between the two. So I'll give you kind of a general overview. One of the things is our software design engineers in the Windows group are truly software design engineers, okay? They are writing a complex code to do tough stuff in the operating system. They write all the API level tests for the Win32 APIs. They test all the kernel components, all the device drivers that ship in box, etc. To give you an example of how complex our work is sometimes, I know one testing team where the developer wrote his own device driver, defined his own ioctls to communicate with that device driver, and then wrote the user mode application to drive the test within the kernel mode space of the operating system. And if you've ever written device drivers, that's not a simple task. He's basically writing device drivers for a device that doesn't exist. He's really writing them to exercise components within the kernel of the operating system. And so his device is the APIs and the input-output methods within the kernel space that the device drivers can exercise. I also know a tester, a developer in the test group that works very closely with the developer for the memory manager. And so some of those tests were actually built into the product so that all of the test organization can leverage those features. That helped the team significantly to find memory leaks in the operating system, expose page faults within the operating system, and page boundary faults, things like that. So that's like the most complex type of work that a developer in the test group might do, which is equally complex on the product side of the house. The software test engineers, oftentimes their role is also an automation type role. They may take existing testing tools that somebody's developed and write automation scripts to exercise components in the operating system. Oftentimes they'll write Visual Basic programs to exercise at a UI level, to run as applications, and also track the test results and logging of test results. Typically, the tests that the developer and the software test engineer create are typically handed off to people to run over and over in the lab as part of the regression test process. These tests are also made available to the development engineers on the product side so that they can test their code before they check in. Okay. So there were 3 key initiatives that we focused on during Windows 2000. The first one we're going to talk about is compatibility. The second one's reliability. And the third one's deployment. In compatibility, we focused on hardware compatibility and software compatibility were the big focus areas. We wanted Windows 2000 to be very compatible with the hardware and software out there. In hardware compatibility, we were supported over 10,000 devices. We supported over 5,000 OEM systems, and over 100 hardware vendors were shipping systems when we launched the product. We had good buy-in and support from our vendors. This was a key focus. There were typically weekly meetings just to target this area. Software compatibility, there were over 7,000 applications supported when we shipped the product. Now, we did not test all 7,000 internally. We tested, I think, a little over 1,000 applications internally. The rest of these were through various programs where we work with our joint development partners and our independent software vendors to get them signed up to support Windows 2000 at the launch. There was an internal test organization focused on productivity and server applications. That's where we tested the 1,000 plus applications. We also worked with our customers and partners to test line of business applications. We did a couple of things here. One was we worked closely with our joint development partners to bring them into Microsoft so they could set up their environment in our lab and test their line of business applications. We also had an ISV lab, Independent Software Vendor Lab, where vendors could bring their development process into our space. And they essentially said, yes, we're going to support Windows 2000, but we'd really like your help. So they'd come here many times with all their source code and their development systems, go into our lab, test on the latest version of Windows 2000, oftentimes the previous week's IDS build, and look for bugs. And if they hit bugs and problems, we'd have our developers go down and help them right in the lab. They were just thrilled to be able to have that kind of access to our development team to ensure the operating system works properly and that their application is going to work properly when we ship the product. We also sent some teams out to our key customer accounts. We had a SWAT team that would go out once or twice a month to key customer accounts, go into their test labs, bring the last week's version of the operating system, and they might test 20 or 30 line of business applications with the purpose of looking for incompatibilities in the operating system. And I know in 2 cases, I know for a fact, we sent key developers out to those sites because the customer found some incompatibility with an application they had developed in-house. The second area we focused on was on reliability. And we did a lot of testing in this space to ensure that we created a more reliable product. You've probably seen the ads now, the 5.9 ads. If you haven't looked at the website and looked that up, that's based on real customer data since we shipped Windows 2000. That was not our data. That was real customer data that we collected after we shipped Windows 2000. But we focused significantly on this. The simulation of peak loads was done as part of our long-haul testing. We'd take a common scenario like an IIS server, and we'd set up, we'd take a Microsoft.com site, for example, and then start issuing get pages off that site and simulate the load on that site over a period of time. We do the same thing with our file servers, our DHCP servers, our domain controllers, our print servers, our terminal servers. We just put a heavy load on those machines 24 hours a day to ensure that they'd stay up and not fall over after some period of time. And this was a great tool because we did find some leaks. If you had some small leak somewhere and, gee, it was only a 1K, it's kind of hard to see a 1K leak on a machine that's got 4 gig of RAM. But you let that run in a real-world transaction environment for about a week to 10 days, guess what? The leak becomes fairly visible when suddenly your system is doing nothing but paging. And so that drove the quality of the product up significantly. We exposed a lot of bad bugs through that kind of testing, so our customers wouldn't see them.
So how long-term is long-term? A week, 10 days?
At RTM, we ran 2 weeks. 2 weeks load. And so most teams equated that to 6 to 9 months of real data at a customer site. These were not small machines. Most of these, they'd range anywhere from dual proc, typically, up to 16-way systems, depending on the component area and the testing that was done in that space. But most teams targeted a 6 to 9 month simulation when we RTM'd. The MTTB is mean time to blue screen and mean time to reboot and availability of machine. Over an extended period of time, in roughly 1 to 1.5 years, we tracked very closely all of our long haul and deployment servers internally and at ITG to ensure they stayed up and that we increased the time between reboots and the times to blue screen. Okay. We also compared that with NT4, Service Pack 5, and Service Pack 6. We wanted to prove to ourselves that Windows 2000 was more reliable than NT4 was. And we did that. That was our goal. We achieved that goal before we shipped Windows 2000. We did that by just measuring all of these statistics on these machines and on these servers over that period of time. And we accomplished our goal. Windows 2000, when it shipped, was proven internally more reliable than NT4, Service Pack 5, and Service Pack 6. So when I heard about the 5.9's ad campaign, I really wasn't too surprised because we knew it would hold up. We also had Driver Verifier, significantly reduced the number of blue screens in the product, a very effective tool that we used. Prefix. Prefix is a tool that we acquired and used. It's basically a source code analysis tool.
You can kind of stop. You've got most of the prefix team here.
Oh, okay. Well, I'm going to talk about that anyway, but the prefix, because we've got some people that are also virtual here watching, so the prefix tool was good because it did a source code analysis and helped us find a lot of bugs that we hadn't hit yet. Okay, and to increase the quality of the product without having a machine failure and without having to debug the machine. We also increased and improved our leak detection and leak monitoring tools that we had available. Both tools we had available and also through our memory management tools and building that into the operating system to become better and looking for those leaks. This was also a key focus of the test teams. Most test teams had some people solely focused on leak detection and leak handling. We also tracked over 5,000 customer site servers were tracked through our JDP programs with our customers. And we did kind of sanity checks. Because we were getting metrics from several different places, we always compared those metrics to ensure that the data looked reasonable, that there was reasonableness applied to the data we were analyzing to ensure we weren't out of sync anywhere. And we had great correlation of data between all those reporting places. The other areas is deployments. And I already talked about eating our own dog food. But we had staged deployment plans for all our key services. We worked very closely with ITG and with our development partners. We did a lot of end-to-end scenarios deployed within the organization. The Windows 2000 team ourselves, we were self-hosted for over 2 years on recent versions of the operating system all the time. We also deployed some 70,000 desktops and over 2,000 servers before launch, both within Microsoft and at our joint development partners. Several .coms went live. We had, I know of one site, a large site deployed for the 1999 Christmas season on an IDS build of Windows 2000, and it handled all of their transactions for them during that season. Let's see. So that's basically all I've got to talk about here. Question?
About deployment, do we have any tools to track bugs at the customer, to do it fast, to do it automatically, to do it in any way?
So the question is, do we have tools that track customer bugs automatically? Is that
I could, yes. Like to debug remotely.
to debug remotely?
Do something, I don't know.
Okay, so we do have tools that during beta testing, when a customer encounters a problem, they have an easy way to report that problem to us, yes. And we have a team here in the Windows division that's, it's their job to collect all that data, analyze it, look for redundant reports, duplicate reports. They also try to set up repros of the bug. They get the bug into our database. They're our frontline screening process.
But we don't have a process to get the state of the machine and to, like a dump file, and to do something with it?
Depends on the failure. For example, if it's an application failure, we can take I think they would send in the Dr. Watson log.
Yeah, Dr. Watson.
Yeah. And if it were a blue screen, there's a memory dump. If there's a blue screen, there's a memory dump of the failure, and they can send that to Microsoft also for analysis. Yes. And actually, in Windows XP, those tools are enhanced much more than they are in Windows 2000. This is, in fact, a key focus area of one of the teams in the Windows XP product that's focusing on making it easier and to get more accurate data so we can more easily fix the failure. Yes?
So what could be better?
What could be better?
Yeah, in an engineering process, and we know that Windows 2000 is shipped, you must have done a post-mortem.
Okay, so the question is, what can we do better than we did in Windows 2000? And I guess what you're really asking me is, what are we doing for Windows XP in testing? We've got, well, that's almost another presentation. And in fact, we're working on that now. I'm going to do a presentation next week that's going to talk more about to a development team about what we're doing in the Windows XP space than what we did on Windows 2000. But yes, we did do a post-mortem. Yes, there are areas we are focusing on more intensely than we did on Windows 2000. I don't know as I can think and remember all those off the top of my head.
Is there a summary of that post-mortem available?
Yes, I know I can find it. I don't know where it is right offhand. If you want to send me a piece of email, I'll be happy to dig that up or have somebody send that to you. Yes?
I'm curious. There's a whole academic discipline around software testing methodology, right? Would you say that there's a place for those ideas at Microsoft, or are we doing our own thing relative to what's being taught at universities?
So the question is, how does Microsoft integrate from the outside world?
Well, would you describe the Microsoft test as an academically oriented operation, or are we focused enough on our own tools and processes that we're really making any attempt to integrate new ideas that are going on from research?
Okay. I think there's a couple of questions in there about how Microsoft receives testing theories and technology from the outside world is one part, I think. And the other is how well we integrate that.
Right, or do we just continue with our...
Are we just heads down?
Are we doing the same thing we did in 1990, right?
Okay. So let me attempt to answer that. And no, we're not all heads down. Okay. Many teams are integrating new ideas about software testing and technology. I know the IE team has gone to a model-based testing. And I think James Tierney and Harry Robinson have done some lectures at software testing and quality conferences over how that's accomplished, right, and the impact of that. I'm actually in the process of spending some time, in a couple weeks, I'm going to spend some time with the IE test team to learn more about that process. I know the Shell team is now using a process I'm not familiar with. I'm going to go find out what they're doing. One of the things that's happened in the past year or so is Microsoft is actually getting better at going out to the software testing community and giving them information. I presented this similar presentation at Star West last October, and to about 100 people, and I was just amazed with the response afterwards. People came up and said, "Thank you so much for sharing with us how Microsoft does their testing." We are more actively involved with the EBC, the Executive Briefing Center. Many of the companies that now come in to visit Microsoft at EBC are coming over to the NT or to the Windows test labs, and we're kind of giving them a shortened version of this presentation, and we tour them through 3 or 4 of the key labs over in the Windows division, in the Windows XP group right now, to give them more exposure to our testing. One of the best examples I have of how we we, Microsoft, could communicate better is a couple years ago, there was a journalist wrote a pretty scathing article about a beta version of our product. They had hit a bug, like instantly they hit a bug. And the article basically said, gee, doesn't Microsoft try this stuff? And the manager of the test group at the time contacted the journalists and invited them to come visit our facilities and gave them a tour of all the test labs, talk about our test cycles, how many thousands of machines are running tests 24 hours a day. And by the time they left, they were just overwhelmed. They couldn't believe how much Microsoft did to test their products at that point. Just the opposite of the perception they had before. We need to do a better job at that as a company, and we are taking actions to accomplish that. But yes, there's quite a few that I know several people that they have key contacts to testing people in the outside world, as it were, that review these different testing theories and techniques and come back and try to encourage deployment or testing of those scenarios and things. I visited one of the Windows test groups 2 weeks ago, and they showed me some automation they had put in place for, in my opinion, difficult scenarios. It was a hard problem many teams struggle with. And I saw it, and I'm like, this is just incredible. You know, how did you do this? Well, we put some guys together and said we need to get better and become more efficient at the way we automate this aspect of testing. So, yes, we do a lot of that interaction.
Continuation of this, probably the most important development in the academic community and in hardware companies was model checking. So Intel and others hire a lot of people to develop and use model checking. Is this reached testing parts of Microsoft?
I haven't heard of model checking, no. And I don't know if any teams have investigated this or if they're deploying it. Has anybody here heard anything? Or
IE team is doing something, they're calling it model-based testing.
yeah, I know they're doing model.
This is very different.
Oh.
Yeah, it sounds. I haven't.
But in regards to research and academics and tests, Microsoft actually grants a lot of money into academic research and funds a lot of it. We funded, for example, 2 years of research into test prioritization based on code changes. We have academic researchers who actually have liaisons at Microsoft for their university that they're like, I want to research this aspect of testing. Who do I work with at Microsoft who perhaps have access to source code or test results or whatever, and to talk about the results of that. So we actually have a fairly complex system set up to actually, a comprehensive system to allow
I'm
for
not
that.
so sure. With all this complex system, there is a major development, namely model checking, which is unknown. So there is a problem there, it seems.
Right, I don't know what model checking is, but I know a little bit about model testing. So it depends. Has anybody looked at, even in the academic, applying model checking to testing? We don't know yet. You know, maybe there is somebody, but I don't know.
There's thinking back, right offhand, I know of 3 different groups that are funding research at universities, just with the contacts I have. So I know there's got to be a bigger list. And I know several years ago I went to a lecture here on campus from a I think PhD candidate that Microsoft was funding research on. I think what was it called? Data path testing, I think was the name of it. So yes, there is a lot of research that Microsoft funds in the testing space. And if you're on the alias to get announcements of lectures that come into Microsoft, there's typically, I think, like 1 or 2 a year that are very test-oriented, test-focused, and they're basically reporting current status of their research. Any other questions? Well, thank you very much for coming. I hope you enjoyed this. Thank you. My email is terryla, Terryla. If you have any follow-up questions or want to know where the postmortem is, feel free to send me some mail.